These clocks began as identical objects, same atoms, same design, same oscillations. But after scientists separated them by a small change in height, they no longer agreed on what time it was. The difference was microscopic, billionths of a second, but the physical implication was devastating. For most of history, we assumed time was universal. Isaac Newton imagined it as a cosmic background rhythm, an invisible river flowing identically for every person, mountain, and star. Because ordinary life never challenged it, the assumption survived for centuries. In 1915, Albert Einstein proved that mass curves the geometry of spacetime. Gravity is the physical result of that curvature, and the deeper you sit within it, the slower time passes. This equation describes gravitational time dilation. Notice the variable h, representing height difference. In this calculation, raising a clock higher above the Earth mathematically forces the resulting time rate to increase. This distortion stays hidden from our daily senses because of the denominator, the speed of light squared. At roughly 90 quadrillion in SI units, it suppresses the effect so completely that a second always feels like a second to a human observer. But the math is literal. Every centimeter of altitude moves an object into the future faster. By raising a clock, you are physically breaking the concept of a shared reality. To see this fracturing in action, we begin a vertical descent from 20,000 kilometers above the Earth. This is the domain of GPS satellites, where the planet's gravitational pull is significantly weaker than it is on the surface. This chart tracks the daily mathematical battle occurring in orbit. Because gravity is weaker at this altitude, satellite clocks tick faster than those on Earth, gaining about 45 microseconds every day. At the same time, the satellite's extreme orbital velocity triggers special relativity, which slows the clocks back down by 7 microseconds. When these competing forces settle, the satellite clocks maintain a net gain of 38 microseconds per day. Without accounting for this tiny discrepancy, GPS errors would accumulate by kilometers within days. Your smartphone only knows its location because the software corrects for the fact that time moves faster in space. As we descend into the atmosphere, we move into the late 20th century, where timekeeping shifted from mechanical gears to quantum transitions. Using cesium-133 atoms, scientists could finally measure time with enough precision to detect relativity across the sky. In landmark experiments, researchers flew atomic clocks aboard commercial airplanes while leaving identical units on the ground. When the planes landed, the clocks no longer matched. The combination of speed and altitude had permanently severed their synchronization. At these altitudes, the fracturing of time is a strict operational requirement for modern civilization. It is an engineering reality that dictates how the digital world functions. On the surface, the distances required to prove Einstein right became even smaller. In 1959, physicists used Harvard's Jefferson Tower to test time dilation across a height difference of only 22.5 meters. They measured gamma-ray photons climbing through the building. As they moved against gravity, the photons lost energy, a gravitational redshift that proved time was flowing at a different rate in the basement than at the top of the tower. To reach the current frontier of precision, we must descend below the crust. Deep subterranean tunnels provide the isolation needed to run the world's most sensitive experiments away from the noise of the surface. Researchers now use optical lattice clocks, probing atoms with lasers at optical frequencies. These devices are so stable they would lose less than 1 second over the entire age of the universe. With this level of resolution, moving a clock vertically by mere centimeters underground produces a measurable change in the flow of time. This precision has enabled chronometric geodesy, where scientists use the rate of time to map the Earth's interior. Local gravity shifts caused by mineral deposits or mountains alter the local clock rate, proving that Earth's mass fractures time right beneath our feet. Imagine two synchronized clocks taking different vertical paths through spacetime and reuniting. When they meet, their elapsed times differ. This wasn't caused by a mechanical error. Gravity physically warped the geometric path of time each clock traveled through. Each clock experienced a different number of moments. This physical reality extends to human biology. A person sleeping on the top floor of a skyscraper ages infinitesimally faster than someone in the basement. The difference is too small to notice, but physics measures it nonetheless.
The universe is under no obligation to match our intuition. Space is not a rigid box. and time is not a universal constant shared equally by everyone. In the silence of subterranean labs, the clocks continue to drift apart. They remind us that a universal now is an illusion. Time was never flowing evenly for any of us.